Chapter 8, Thunderstorms, Mid-Latitude Cyclones, and Hurricanes. Section 8.3, Air Masses and Transitional Fronts. So if you looked at the Earth's surface, you'd see that it's covered with various air masses. And an air mass is a large body of air that has similar temperature and humidity characteristics. They can cover thousands of square kilometers. Air masses are classified according to the characteristics of the source region or area of formation. Air masses can have 4 temperature attributes, and these attributes are a function of where they form. If an air mass forms near the equator, it's equatorial. If an air mass forms in the subtropics, it's tropical. And in the mid-latitudes to high latitudes, polar. In the poles, it could be an Arctic or Antarctic air mass. Air masses are also classified depending upon their moisture or humidity characteristics. They can either form over dry continental areas or moist maritime areas. Combining these two categories gives us a number of possibilities for the types of air masses that might be found over North America or associated with North America. You can have maritime polar, continental polar, maritime tropical, continental tropical, and continental Arctic. This diagram here shows regions of North America where these air masses form. So you can see Arctic air masses tend to form over Alaska. They usually originate from outside of Alaska, Siberia. Maritime polar can either form on the east or west coast. Maritime tropical, once again, either east or west coast, but further or closer to the equator. And continental tropical tend to form in the middle of the U.S. Continent, Mexico. Continental polar, northern Canada. Frequently, two air masses, especially in the mid-latitudes, come together and develop a sharp boundary between where they meet. And this temperature difference can become intensified. Such an area of intensification is called a frontal zone or front. The boundary between warm and cold air masses always slopes upwards over the cold air. The cold air is more dense, the warm air is less dense and flows over the cold air. The slope of warm air over cold air leads to forced uplifting, and this is known as frontal lifting. This produces clouds and precipitation, and these clouds and precipitation are located near or at this boundary zone, this frontal boundary zone. If the air masses are not moving relative to each other, we get a front called a stationary front that occurs. Where air masses are moving, either you can get cold or warm fronts developing. So here we see a typical cold front. Essentially what's happening is the cold air is moving, pushing the warm air ahead of it over its frontal zone, higher up into the atmosphere. You can see I've illustrated here a zone of cloud development and precipitation. On a weather map, cold front is represented by a line with triangles on it. So here's some of the weather associated with the cold front. So in terms of temperature, prior to the passing of the front, the location would be warm. Then it would cool suddenly, and then when the front passes, it would get cold and continue to get colder. Pressure prior to the front decreasing steadily. Contact with the front leveling off, then increasing. And then after the passage of the cold front, you would get an increasing atmospheric pressure. In terms of winds, prior to the passing of the cold front, the winds would be from the south to southwest. Contact with the front, they would suddenly get variable and gusty. And then after the passage of the cold front, the winds would change from the west to the northwest. In terms of precipitation, prior to the passing of the front, light showers, and this precipitation would increase in intensity as the front approaches the location. With contact with the front, you would get heavy rain or snow, hail sometimes, if there's thunderstorms associated with the cold front. And then after the passing of the front, the showers would disappear and the skies would clear. In terms of clouds, prior to the passing of the front, we would get cirrus, cirrostratus, changing to cumulus and cumulonimbus. When we get contact with the front, cumulus and cumulonimbus. And then after the passage of the front, the clouds would be scattered cumulus with blue sky in between them. Here is an illustration showing a warm front. So in a warm front, what we have is advancing warm air moving up over receding cool air or cold air. We get a much more extensive layer of cloud development because the front is not as steep. On a weather map, the symbol used would be half circles, with the front being represented by a line and, as I said, these half circles. The front is moving in a left to right direction. Here are the weather characteristics associated with the passage of a warm front. So think, you're at a location prior to the passing of the front. Temperature would be cool, pressure would be decreasing steadily, winds would be from the south to southeast. Precipitation would be showers, snow, ice pellets, or drizzle. Clouds would be cirrus, cirrostratus, altostratus, nimbostratus, and then stratus. When the location comes in contact with the warm front, there'd be a sudden warming. The pressure would level off, winds would become variable, precipitation would go from being heavy to light, commonly light drizzle. Clouds would be stratus, sometimes nimbostratus. After the passage of the front, you're moving into warmer air, so temperature warms up, levels off. A slight rise in pressure, then followed by a decrease. Winds would change from the south to southwest. Precipitation, there would be none. Skies are clearing, so clearing skies with scattered stratus, sometimes scattered cumulonimbus. Another type of front that can form, these fronts are called occluded fronts, and they form when a fast-moving cold front overtakes a slower-moving warm front. Two types of occluded fronts are generally recognized. A cold type occluded front occurs when the air behind the front is colder than the air ahead of the front. And then the other type is a warm type occluded front. Here the air behind the front is warmer than the air ahead of the front. Shown in the diagram is cold type occluded front, and the symbol on a weather map for an occluded front is as follows. So triangles and half circles alternating along a line indicating the location of the front. So here we can see very, very cold air to the left, receding cold air to the right, and warm air being forced up between these two air masses, and that creates the zone of cloud cover and precipitation.